Let's do this. Okay, exponent rules. Here's the deal. As we go through this, I'm going to fill in some of the stuff up at the top, just kind of as we go. So let's hold off on this, and we're going to develop our understanding of exponents. You've possibly seen this before, and so this shouldn't go too slowly. So if I have 2 to the third, if you know it's 8, that's fantastic. Don't say it's 6, because it's actually not. Here's what it is. It's really 2 times 2 times 2. Now, you know that, but I'm developing our understanding in the process of doing this. Well, 2 times 2 is 4, times 2 is 8, so this is 8. Okay, just saying, that's just going to help us lay the groundwork for the rest of these. I know there are a lot, but they're going to go pretty quickly after a while. 3 to the first, that means I have 3, and there's just one 3, so actually that's it, it's just 3. Negative 4 squared is negative 4 times negative 4. Well, a negative times a negative is a positive, so it's that. Now, be careful on this next one, because we might say, oh, negative 4 squared. Well, negative 4 squared and negative 4 squared are two separate ideas, and they sound the same, but the way it's written is very different. Here's the deal. This one actually is 4 squared, but the whole thing should be negative when we're done. So negative, or we'll change the sign of it when we're done. So negative, then 4 times 4. Well, 4 times 4 last time I checked was 16, but there was a negative in the front. So notice the difference in these, and the calculator actually knows that. So then we get to the ones that get a little bit crazy, starting with one with the fraction. So 1/2 to the 4th power. Well, that means 1/2 times a half times a half times a half. And as we do that, we'll multiply across the top and multiply across the bottom. We really have 1 times 1 times 1 times 1. Well, that's just 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, and that's what we have. I'm going to go ahead and jump ahead just a little bit, because in a few minutes we're going to get to some problems that are similar to this with variables. So I just want to point out something. Switch colors just because. This is the same thing as saying 1 to the 4th power and 2 to the 4th power. It's the same thing. 1 to the 4th is 1, 2 to the 4th is 16. It's completely the same thing. Okay, when we do the next one, we have to be careful that we follow the order of operations. It's something you know, but it's easy to forget when to do what. So what we really have is 4 times 3 squared. Well, that's 3 times 3. And if you wanted to do this first, you could, but technically we can go from left to right. So that's 12. 12 times 3 is 36. Either way, you're going to get 36, even if you said 9 times 4. Okay, that just lays the groundwork as we move into some other stuff. Just do a couple more real quick with some substitution. 2 times 5 to the third. Why do you know it's 5? Well, because I said so. So let's go ahead and do this. 5 to the third. 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. 2 times 125. That's 250. Okay, next one. Let's be careful. 9 divided by, I'm going to write it wrong, but do it right. And I'll clarify. You'll see what I mean. So 9 divided by negative 3 squared. Okay, that's actually written incorrectly because I'm squaring the entire thing. Again, notice the difference between these two up here and the fact that I need that entire negative in parentheses. So what we really have is 9 divided by, well, negative 3 squared is negative 3 times negative 3, and that's positive 9. 9 divided by 9 is 1. Okay, well, we have done that to lay the groundwork as we proceed to some of the other ones. So let's do it. 2 to the 4th times 2 to the 3rd. All right. So what I have is 2 times 2 times 2 times 2. Oh, no, there are 3 more of them. 2 times 2 times 2. Okay, that seems excessive, and it is, which is why we're very quickly going to discover a shortcut on this. 2 to the 4th and 2 to the 3rd. Now, in case you care, this is 16 and this is 8, but let's not even go there. How many 2's do you have? Well, 1, 2, 3, 4, 5, 6, 7. I have 7 of them. Well, you know what? Here's the shortcut. 4 plus 3, boom, got it. That's it. It's that simple. So whenever I am multiplying, the product means multiply, then I'm going to add the exponents. Now, just for the sake of completing this, 2 to the 7th power is 128. Okay, this next one's not going to be as easy. 4 squared times 4 to the 5th. Now, if you want to go ahead and jump straight to the answer, you can, but just to clarify where that comes from, that's 4 times 4, because it's squared, And then 4 to the 5th is 4, 4, 4, 4, 4. There are 5 of them. And if you added them together, well, if you totaled them up, there would be 7 of them. So 7 to the 4th power. I just said that backwards. 4 to the 7th power, because it's 2 and 5. So 4 to the 7th power, I don't know what that is off the top of my head. 4 to the 7th power is an enormous number, and 16,384. That's it right there. Okay, so we can continue with this process by writing them all out every time, but let's not. Let's go ahead and write down what we know. We know the product rule for exponents. We just discovered it. So if I have, I'm going to call it a to some power, m. Now don't panic because we're using variables, because I'm using variables so we can have a generic case for it. So a to the m times a to the n. It sounds confusing, but just pretend like there are numbers there. That gives us a to the, okay, what would we do to them? Well, what did we do down here? How did we get a 7? We added them together. So it's the same thing, m plus n. We're going to do something similar in each one of these boxes. So now that we're back to having actual numbers, mostly, we can proceed. X to the 2nd times x to the 5th. Well, if I'm multiplying, that's a product, I'll just add them together. And in this situation, see, I told you they're going to start going fast. In this situation, I'm going to have y to the, okay, now hold on. I have a 3 here. What do I have here? It's an understood 1 exponent. So I really have y to the 4. I'm just adding. That's it. That really is it. Now, it does get slightly harder when we throw in more than one variable or we have coefficients, but it's not going to be terribly complicated. The hard part about this is knowing when to do what. So let's proceed. Y to the, well, add. And you might have to add more than a couple things. 3 plus 2, well, it's 5. 5 plus 7 is 12. That's it. Okay, next one. All right, let's stare at this for a second. We have a 2 in the front, we have a negative 3. Now, technically we're multiplying, which means we add our exponents, but that doesn't mean that I add the coefficients. That doesn't mean that. So I'm going to still multiply 2 times negative 3. Well, that's negative 6. So don't add 2 and negative 3. But I will add the exponents. 2 plus 5. That's it. Okay, looking at this, I don't see any coefficients. Understood 1s, but that doesn't change anything. We have an x and we have a y. So we're going to look at the x's and add those together. We're going to look at the y's and add those together. So for the x's, I have a 2 and I have a 3. And I'm trying to find a pencil and I can't find one. I had one. There it is. There we go. I was going to use it to point. Walked halfway across the room trying to find it. All right. I have a 2 and I have a 3. So x is to the 5th power. Well, the y's, I have a, well, what's that? It's a 1 and it's a 2. So I have a 3. All right. Let's keep going. Let's not slow down. In front of this one, it's obvious. In front of this one, the coefficient is a negative. Well, it's technically a negative 1. So we're going to multiply negative 1 times 3. We get negative 3. And then we're going to do a to the, okay, let's add them together. 7 and 1 gives me 8. B to the 4 plus 9 is 13. Okay, that pretty much wraps up the first rule, the first thing that's up there, the product rule for exponents. This next one is going to hit on this next part right here, the power rule for exponents. We have x squared to the 3rd power. What in the world does that mean? Here's what it really means. It means I have x squared, but I have 3 of them. So I have this one, I have this one, and I have this one. Okay. So what I really have is, oh my gosh, I know how to do this. 2 plus 2 plus 2. There it is. Okay, let's do the next one. This one's going to take just a little bit more time. I have 5 to the 3rd. Oh wait, I don't just have 5 to the 3rd. I have 6 of them. I need to write 6 of them. Now if you don't want to write 6 of them, no one's going to beat you up. It's perfectly fine. because there's a shortcut that's staring us in the face. At this point, I would just say, well, I know I have a base of 5. By the way, that number at the bottom, or variable at the bottom, is called the base. And we're going to add the exponents. 3 plus 3 plus 3 plus 3 plus 3 plus 3. Oh, well, you know what? When I add, check this out, 6 3's together, I get 18. All right, let's drive the point home one more time. So if I really have y to the 8th times y to the 8th, I have y to the 16. I can add those. Well, I don't want to write that every time. There has to be a shortcut, and there is. Here it is. 2 times 3 gives me 6. Hopefully you've noticed this by this point. 3 times 6 gives me 18. 2 times 8 gives me 16. So let's slide up for a second. The power rule for exponents. If I have some base, a, to some power, m, and I'm going to take that whole thing and raise it to some other power, then that's what I have. I multiply them together. If it's a power to a power, multiply. All right, so the next problem looks a little different, but that's okay. Here's what we really have. I'm going to write one extra step on this next problem. We have x to the first and y to the first, and it's to the third power. Now, what we just wrote up at the top applies, but it's going to be a little different because now we have an x and a y. But don't panic. 1 times 3. We have x to the first times 3. Well, that's x to the 3. We have y to the first times 3, and we multiply those together as well, and it gives us this. Some people make this a separate rule, and technically it is. They call it the distributive property of exponents, and you can do that. You can say, well, 3 times 1 and 3 times 1. It's fine. It works. Okay, let's flip the paper over. Keep on moving. We have 2a to the third power, which means we really have 2 to the third power and a to the third power. And we'd love to stop there, but let's be realistic. We know what 2 to the third power is. 2 to the third power is 8. 8a cubed. All right, let's keep going. We have this disgusting mess here. What we're really doing is distributing this 2 to everything. So let's do it. We have negative 5 squared. Oh, wait. That negative 5 is squared. That whole thing is squared. X to the 2 times 2 is 4. If it's a power to a power, multiply. Y to the 3 times 2, 6. And there's a little 1 here. Z to the 1 times 2, well, that's just 2. There we go. All right, 25. X to the 4th, y to the 6th, z to the 2nd. There it is. Okay. For the next problem, I'm going to start by putting a negative 1 in the front right here. And that gives us negative 1 to the 5th power. Every single piece of that, every little multiplier in there gets that exponent. Negative 1 to the 5th, x to the 5th, and y to the 3rd to the 5th. Oh, wait, that means I multiply. Okay, and you could write it like that, but you're not quite done. Negative 1 to the 5th power is negative 1 times negative 1 times negative 1 times negative 1 times negative 1. That is, well, negative 1, x to the 5th, y to the 15th. Okay, let's pause here for just a second. And let's flip back over. Let's look at that. That's going to guide us into the next problem.